Hello everyone, I hope my audio is recorded. All right, so as the title of video says itself, what we are going to do is I would be showing you how to route the particular request to particular Uvicorn worker, right, compared to just round robin. All right, so GitHub is here, ldcorn GitHub. If you don't want to watch a video, do take a look at the README and specifically read this for you section so you have a full idea of when to use it and when to not use the ldcorn, right? So normal Uvicorn deployment, how it is that you have your load balancer, nginx, client sends a request to load balancer, then moves to nginx, and then you have your application running here, right? This is your app. Man, I really need to improve my motor skills, but basically you have your app and then Uvicorn or the OS itself handles the round robin for these particular workers which you created, right? Depending on your CPU. For example, we have 6 workers. All right. So request goes round robin, whichever worker is free takes up the request. Now, what if you have the requirement to have a dedicated workers for particular task? What I mean by that is that let's say you want these 2 workers for IO, right? And you want this 3 workers for machine learning, and you want this for something else, let's say SSE or webhooks, web sockets, whatever you want to have it. And then what you need to do in the standard way is that you need to split your application into separate microservices, right? You have your app 1, you have your app 2, you have your app 3. You need to manage all of this CI/CD pipelines and everything. And there is nothing wrong with that. If you have resources and time, specifically enterprise, then go for it. This is a perfect approach, right? Splitting up into the microservices. Now, the ldcorn is a different story. What ldcorn allows you to do is it allows you to group those workers based on your specific type of request you want to group them. So, for example, this is ldcorn config.py. You need to make a single Python file. The reason why we have a Python is because you get this, ID completions and also less chances of making a mistake, right? So you create a 1 worker group, right? Default example apps.app. Basically, this app I'm running, this does not need to be a same app, right? You can have a worker group which is running different app if they are sharing the same virtual environment and they don't have dependency hell, then obviously you can use it. Otherwise, just run a single app. So you can have ML routes, right? I want to run for 1 instance. IO 3 instance, WebSocket 1 instance. Do you want to reload them on SigHub or not? All of those configurations are there. I'm moving very quick because I want to shorten this video. How much time has been spent? 3 minutes. All right. I want to shorten the video as much as I can. But yeah. So what happens, request comes, right? If it is an IO request, then IO 3 workers are going to take this request and they are going to handle it, right? These 2 worker groups will never see that request. What this allows you to do is that if you have ML model or any type of requirement generally, but just ML is an example, you don't need to load that ML model into all of these separate workers, right? Let's say if you have ML model with the 100 megabyte RAM, or sorry, 100 megabyte size, you would waste around 600 megabyte of RAM here, right? In this, you don't need to. You can have a lazy load and only 100 megabyte of RAM is used, and only this particular worker is going to do that. So if this crashes, these 2 are completely fine. If there is a blocking code in this or anywhere, right, all of these workers remain unaffected without having the overhead of managing all of those CI/CD pipelines. This is very important for if you are working on, let's say you are a solo developer, you are in startup which does not have this much resources. Sorry about that. And also you don't have, you are working in the service biz like me, where you have to handle all of this. You are working with multiple clients and there is constantly new requirement is coming up, right? You can't have time to decide your architecture and constantly change those architecture when you want to just scale and complete and ship the features, right? So at the time, ldcorns gives you the shortcut which you need and gives you a very big breathing room, right? The example in this benchmark of my README does not do justice to the repo because I just went with giving a basic example of what if you have a blocking code. So, in here, then I just showed here that there is a blocking code in math and heavy, right? So those 2 collapse, but these 3 work, but the IO didn't collapse, right? So basically, yeah. That example I gotten with, but generally you don't need, ldcorn is not designed for this. What I mean by that, isolating blocking code, well, it does provide you a breathing room to isolate your blocking code, but you should check out loop sentry, which is another of one of my tools, which allows you to find all of those blocks in your application, right? Ldcorn doesn't, basically, I'm not suggesting you guys to keep your blocking code, right? I'm not suggesting that. Make it async, but you have a breathing room. You can have this requirement for, let's say, you want to serve a premium group, different workers, right? You want to have unlimited concurrency for your premium group. You want to have a 50 max requests per second for a particular type of users, all of that, right? You can do that based on path. All right, so that's basically the intro. There are many use cases. I am not going to go into that much depth. If that comes up in the comments, we can discuss it out, or even in the in the GitHub issues, we can discuss that out. Right, let's go to direct example. I am going to run this ldcorn config.py, and this is the simple application which uses MongoDB, right? And we have basic CRUD, db read, insert, delete, upsert, right? And then we have ML, math, and counter and WebSocket. All right, so let's just run the application. As you can see, ldcorn has started all of those. I have set log level to error, so you can see ldcorn logs, right? 3 default IO, 1 ML, 1 math, 1 WebSocket. All right, so let's send 100 concurrent requests for 1 minute. The reason why 1 minute again is just mainly because of I want to make the video as short as possible. All right, so all of these requests are currently bombarding here with this particular worker group workers, right? And let's say during runtime you decided that you want to change. You don't want to have your math group as a separate. I'm just giving you an example. You can have any sort of requirement, right? But this is just runtime update example, and you want to increase the instance size to 2. And let's say you want to increase the instance for this to 4. Right, during a runtime, your application is handling all of this request, right? I send a SIG-hub. As you can see, it is going to spawn, right? Default 3 to 4 instance, spawning one new instance, right? So now what we have, 4 workers, 2 ML, and 1 WebSocket, right? Math group has been removed. All of this while the requests are ongoing, right? The 100 concurrent request is actually a decent load, I would say. Decent load if you are on the Python. 100 concurrent requests is a very decent load, right? Okay, so all right, it's been 1 minute and it has been completed. As you can see, none of the requests has been failed. Delete dummy 10,000 requests for the delete, right? DB insert. We are getting 150 or 154 requests per second, which is fine, right? That is fine. Same with, you can see upsert, none of that has been failed, right? You have DB read endpoint, you have math prime, right? All of those. None of the requests has been failed while you did a runtime reload. A very important thing, runtime reload. And if you see fast IO, we nearly handled how many? 90,000 requests under 1 minute. That's actually pretty nice, right? 1500. Okay, sample payload worker ID, we were just getting the workers into this. And you have obviously your ML pipeline, 70 requests per second, which is very less, but again, it's async IO2 thread. So, right, yeah, I have a pretty good CPU, so it can handle it, but still, yeah. So now what I mean, we can still see, right? Let me just open this. You can see the counter statefulness. If I open it, you can see connected to this worker, get counter, we have 1000. Yeah, right. And if you look at the terminal, how many counter requests we sent, stateful counter 1482. And this is 1483, right? WebSocket is connected to this particular worker, and that worker is only one who is replying to us, right? All of those other workers are, fully unaware of that, right? So zero downtime reloads, as well as scaling up and down vertically, basically gives you a lot of breathing room. Yeah, that is basically what I'm trying to explain in this. Yeah, I hope the video isn't too long. 10 minutes. Very nice. All right. Any questions, you can, reach me out and you can basically make a comments. All right. Yeah. Bye.